This video I will make a quick overview of Nematicity program and different sections it has. This program is needed for combining the measurement set of all temperatures, for example, or all powers into 3 files. First channel, second channel, difference. Additionally, it can calculate average, so it will be file number 4. Or if asked, it will calculate derivative, meaning it will be calculating differences between two adjacent scans by power or by temperature. The top of the program consists of place where you have input file name. You need to input pass to the file name up to the counter. Counter is the number that defines either which temperature is or which power is it. Usually when it's temperature, it's in the middle of the file. If it's power, it's on the very end of the file. Then the first file, the number of counter, if it's temperature 3 kelvins, it's 3, if it's rotation 0, it's 0. And then number of files, how much measurements they were per measurement set, 21, 41, depends. And increment is added for temperature measurement specifically. For power measurements, it's usually 0, because every next rotation is a new measurement. However, you can, for example, you can choose every second power measurement and use only even or odd measurement to use only half of the data set. It is possible too. The next settings are check zero signal based on first. Here you define how much points you are sure that it's the baseline signal before the pump arrives, where you have stable equilibrium reflectivity. And also you need to define the point time delay when you think that 0 time delay when your pump arrives, when your signal starts changing. Lastly, you have renormalize options. This renormalize option will renormalize the transient reflectivity signal. Instead of calculating, for example, delta R by R, when you subtract reflectivity, divide by reflectivity, you just define that 1 is a value before the pump and 0 is a value at some peak, and this peak is defined by what is the central position of peak and how much points you use to in the raw data. I need to insert 100 here, because when I do equilibrium, equidistant interpolation, the number of points increases twice. So if I estimate from the data it's at 50, I put 100. If I from the data estimate is 100, I put 200. For power-dependent measurements, I go in the more details in the power routine. Temperature-dependent measurements in the temperature routine.